Greetings and welcome to the Rock Identification Lab for Earth Science. So you're going to be doing this lab and you're going to be feeling like you're winging it. That's very normal when you're starting on samples for rock identification, especially if you don't have them to touch and feel. One of the really cool things about geology is it's a kind of a touchy-feely science. It really is. Touching is tasting, manipulating, smelling, all of those are things that we do besides just a visual look at a rock to help us identify what it could possibly be. But since we're in an online environment and I didn't want to charge you a whole bunch of extra money to go buy a rock kit, I've taken some photos of 20 samples. So here's what's going to happen. You're basically going to determine, is this rock a igneous, sedimentary, or metamorphic rock? If you didn't do the first assignments of lectures, meaning on the first day or week, depending on your summer or you're in a regular long semester. So that first set of lectures was the rock cycle and minerals. So that should get you started. Rock cycle's the key. You can go over to the Information Festivals folder and actually find that lecture video, as I noted in the course instructor plan, as well as the video about the course. So you need to watch that if you haven't. Get out your textbook and look at the pages that I've indicated. But I'm going to give you a brief overview of how the three different rock groups are different, and then what you're going to need to know about how to find the name for the rock. Okay, so the very first thing I want you to know is that igneous rocks form in a molten format. So they're either magma that are crystallized and cool off inside the earth. So they have bigger crystals that have grown together. They're typically heavier. In many cases, they're very beautiful. Then you have what are called extrusive or volcanic rocks that are lava that crystallize and cool off quickly within days, as opposed to millions of years of the rocks inside the earth. So the textures are phaneritic and aphanitic. Phaneritic basically means magma took a long time to cool off. So it has interlocking crystals, much like a puzzle does. So when you're looking for puzzle pieces, regardless of what color they are, and the rock's pretty heavy, that's one advantage you don't have. So I'll kind of give that information to you as you're going through the lab. So that's what phaneritic is. It refers to all intrusive or plutonic igneous rocks that have cooled beneath the surface. Aphanitic, however, are any types of lava rocks that crystallize at the surface. Crystallize meaning turn into a rock or cools off. So there's basically four subtextures. Is it glassy, like volcanic glass, known as obsidian? Is it holy, meaning does it have rocks, holes in them from old ancient gas pockets, which are called vesicles, and that's referred to as vesicular. And then does it have shards of material like it exploded out of a volcano? That's pyroclastic. And then you get the weird one that has some crystals but lava, but they're not interlocking. And that would be something like olivine basalt, where you have some crystals that come up during the eruption that formed inside the earth, but they're actually in the lava, so they don't get remelted. So that's igneous for you. If you determine your rock's not igneous, then you move into sedimentary. So there's two textures for sedimentary, and it's called clastic, also referred to as detrital, FYI. And then there's chemical. So clastic refers to a texture when rocks are made up of broken up fragments of other rocks and stuff. So basically, they're a hodgepodge of things. The size of those clast or pieces of material dictate which type of rock they'll be. For example, are they a shale, which is mudstone, like paper thin? Remember that when I'm going through the lecture. I'll say something like, oh, that's a paper thin rock. Sandstone, which is coarser. Then there's something between sandstone and shale called siltstone. Conglomerates, which have rounded, predominantly 50% or more rounded clast or sediments in that rock. Or breccia, which has predominantly angular, 50% or more angular sediments and clast. So these are rocks broken down from other rocks. So how does that make it different from chemical sedimentary rocks? Chemical are really cool because They are made from one of two ways, and usually both ways. One is the remains of dead microscopic organisms, and they accumulate and make rock, like limestone. In addition, you can have a reaction occur in water that creates a substance. That's called solution. So when you get this kind of material, you get this solid left over, and enough of that creates a rock. So usually you get the dead animals that are microscopic, and then you get the solution solids. They mix together to make a chemical rock known as limestone. And then another real famous one is chert and flint, which are essentially the same thing, although they're created by a different microscopic animal. In this class, we're not worried about differentiating between the two. So in sedimentary, basically, are you trying to determine, did it form in a broken down rock situation from other rocks, or did it form from dead microscopic organisms, or from a solution in water, like seawater? All right, when we get into metamorphic rocks, things are pretty interesting because metamorphic rocks can be igneous or sedimentary rocks, or even another metamorphic rock that undergoes change. But it can't be melted. I want you to really think on that. It doesn't mean that some of the minerals couldn't be in a molten form, but the whole rock is not. So there are two textures, foliated and non-foliated. So like I can't apply foliated and non-foliated to igneous, and I can't put the igneous texture terms of phaneritic and aphanitic and apply those to metamorphic. Same thing with sedimentary. They each have two descriptive terms for their textures, and the ones for metamorphic are foliated and non-foliated. So foliated refers to metamorphic rocks that basically have their crystals squashed. So that's from pressure and heat. I don't want to say just pressure alone because it's not true. The more heat you get added with that, of course, reactions occur, and really cool rocks can form like schist, and schist is all glittery and shiny. So let me go through some of these foliated rocks with you. Slate looks like mudstone or shale, but it's been compressed more, but it looks a lot like it. So it's just going to be thinner, and it's going to have a harder emphasis to that rock, which I'll tell you as we're going through the samples. Phyllite has a little bit of a metallic sheen, almost a little wave at the top. I really love phyllite. It's pretty. So it's somewhere between slate and schist. But schist is all flaky, shiny, metallic, often has gemstones like garnets in it. So I might mention that in lab. And gneiss, not gneiss, it's a nice rock. Gneiss means banded, so basically it has stripes. So that all comes from the parallel arrangement of crystals. And from slate to gneiss, slate is the lowest grade, gneiss would represent the highest grade of foliation in a metamorphic rock. Non-foliated, the two big ones that we'll look at are marble and quartzite. So marble used to be limestone always, and quartzite used to be quartz sandstone, just so you know. And these don't have that parallel arrangement like you would see in a foliated rock. Instead, they have the puzzle pieces are glued together. So typically the higher the foliation, the more it looks like it's almost melted, but not quite. So, I'm not worried about your grade of metamorphism right now. I'm just wanting you to put it in the right class. Like, is it igneous, sedimentary, or metamorphic? All right, so I'm going to go through the samples, and I'm going to give you some help so you can kind of figure this out. We're going to do the first one together and show you how it works. So you'd look at this rock, and I see a lot of little pebbles and things stuck together, rounded stuff. If you recall me talking about conglomerates, if you'll go back to your overview page that I provided for lab, you'll notice that any rock that has more than 50% of rounded clast in the sedimentary category has to be called conglomerates. You got it. Yay! See, that wasn't so hard. So you really have to blow that picture up maybe if you need it to see bigger, but I can see it clear as day from here. They're all different sizes, and I'm going to give you a little story there. It represents a flood event. Big enough to carry, the water was strong enough and vivid enough to carry these samples or these rock materials. And then once the river died down, they all went and they just kind of made a layer of junk. And that's kind of what conglomerate is. So it represents flooding. All right, sample number 2. Is it igneous, sedimentary, or metamorphic? So I'm going to give you a little hint about it. First of all, it is fairly abrasive, and it forms in can be at a beach or a desert. Maybe that will kind of help you with determining what it is. So remember, it's kind of abrasive, so if you felt it, it would kind of feel maybe like sandpaper, for example. So that's sample 2. Sample 3. This one is unique in the fact that it has all this weird stuff. It's got holes in it, like from gas bubbles. So maybe that should indicate to you, which one of the 3 rocks had the gas bubble thing? And probably felt in that first category we learned about. So go back and look at that. It's very light in color. I'm going to tell you, it came from a very explosive pyroclastic event. So this one's a cool, special rock. And I'm going to tell you, it is one of my favorites because I really like this particular rock. But nevertheless, once you figure out what it is, I'm going to tell you the pink is important when you're looking at your overview paper that has all the choices and the descriptions. All right, so what's this thing? First of all, it feels chalky. That'll be really important to determining if it's igneous, sedimentary, or metamorphic. So it's chalky. It also reacts to acid. So if you watch the rock cycle lecture, you're going to know there's only one thing that reacts to acid, and it has calcite in it. And this rock is made of 100% calcite pretty much. And so that should help you delineate what it is. This stuff is all around MCC campus where Lover's Leap is. So if you want to do a search, if you're not from here, and look up Lover's Leap and look at the white rock, you're going to know what this stuff is. All right, what's sample number 5? First of all, do you see anything that would indicate that it's igneous? Like, does it look like lava? I don't know. Does it? Does it have any clast? I see them, so I would say yes. I don't see that there's been any pressure or magnificent heat applied, so I think we can put it in the sedimentary category. The question is, are they rounded or angular clast? That's going to determine what your sample will be. On sample 6, you probably recognize this right off the bat as being something that you could find in a store for making cabinet surfaces with, or countertops. I have it all the way through my house on my countertops, in my kitchen, in my bathroom, even my fireplace. Really cool. I love this stuff. So that could kind of give you an indication. I see multiple different crystals, a lot of pink ones, and they're interlocking like puzzle pieces. Took a long time for this rock to crystallize, to kind of give you a hint. Is it igneous, sedimentary, or metamorphic? On number 7, kind of give you a little hint on this. I mentioned in one of the overviews that when I said paper thin, that should be kind of a key trigger word. Well, that's what this rock is right here. It's super paper thin. Matter of fact, the sediments that make it up are really, really tiny, almost microscopic. So it takes a lot of them, millions of them, to even make a centimeter thick of this stuff. So it's paper thin. So does that put it in igneous, sedimentary, or metamorphic category? And I bet you're leaning towards one of them, and I'm hoping it's in the second category because it'll help you identify what it is. Moving on to sample 8. This is a shiny rock and flaky. Do you remember me talking about that in the overview? And I also said sometimes it has really cool gemstones like garnets. Well, guess what? This one does. So see if you can figure out what it is. On number 9, I talked about gas pocket holes. So this rock certainly has that. And it also has these little gifts, this little olivine right there, otherwise known as peridot. And so this rock would have to fall in one of those 3 categories because the gas pockets kind of give it away. So this has something called porphyritic texture as you're reading through your material to kind of help you isolate what it could be. All right, for sample 10, right off the bat, you should notice something about the way this sample looks, which is going to put it in either igneous, sedimentary, or metamorphic. It looks glassy. So let that be your guide as to which category it falls in, and then it should be obvious to you which rock that number 10 represents. On number 11, this one isn't nearly as easy, but it is a spectacular rock. If you saw it in person, the picture doesn't really do it justice. It's actually kind of gold in color, metallic. And remember me talking about metallic and that you would see that in one major group of rocks, Igneous, Sedimentary, or Metamorphic. And there was one specific rock that kind of had a flaky metallic sheen. Well, this one isn't flaky, it's that rolling thing I talked about in that class of rocks. So it has little ripples on top, and that means it is a special type of that rock. So see if you can figure out if it's igneous, sedimentary, or metamorphic. And once you get to the class, I think you'll understand that this has a very special texture from pressure and heat that has allowed it to kind of have those ripple marks right on top, and it's metallic. All right, number 12. This is something I love. Believe it or not, that rock is all made up of shells. And it would also react to acid. We had another sample earlier that would do that. So that kind of gives it away, made up of stuff from other stuff, right? So you can kind of say, well, that rules out magma or lava, so that rules out igneous. That's not metamorphic, so it's got to fall in the sedimentary trump. You got that far. So now go look at the descriptions and see what kind of special rock is made up of solely of shells, and you'll have it down pat. On 13, this one is kind of a hard one if you don't have enough information. So basically, this particular rock, I'm going to give you a hint. It's either going to be in the igneous or metamorphic category, but it's not sedimentary. I want to get that right off the bat. So kind of help you there. It's pink. That's important in one classification of rocks. So when you get to that, I can tell you there are no interlocking crystals. So there's none of that, which probably means that it's the other texture. And since it's pink, it'll be very important to you when you look at the rocks to figure out which one it is. So hope that helps, because I think once you look at the group, I almost said it out loud, then you'll know which one it is. Okay, sample 14. I see some holes in it. It's very black. Even looks like it got thrown out of maybe a volcano. That should tell you which particular group that it falls in. Now let's see if you can figure out which particular rock that it is. On number 15, this is a cross-section of a rock. You find these in gravel beds all the time. I want you to notice that it looks like what used to be classed have almost glued together from heat. So we talked about one group of rocks that could be any type of rock that has kind of been undergone a recycling or a change, but not completely melted. Do you remember that one? Well, it falls in that category, but there's no evidence of those rocks having parallel alignments of crystals, so it's almost like somebody glued the little class together as this thing was being altered. All right, number 16. This is a rock commonly that you would probably think of as arrowhead making material. So what does that represent, and which class of rock does that fall under? On number 17, the stripes and bands give it away. I talked about a banded rock that was very friendly. That's this particular rock, and see if you can figure it out from there. On 18, these are mud cracks. They're ancient mud cracks. I just love mud cracks. But the rock is special. So the rock is not super fine in nature, meaning the material or the class that make it up, but it's not like sandpaper. So it's somewhere in between. What's that special rock that's between the fine grained stuff and the sandy stuff? And then you'll know exactly what it is. On 19, you're like, that is a funny looking rock, and it is. As groundwater ate through this rock. Okay, that's why it has holes. And so the holes mean something. If you read your overview, you'll know exactly what it is. But I'll tell you, it does react to acid. So this is the third time we've seen a rock that reacted to acid. So that's going to help you put it in the right category. That means it has calcite and it's made of calcite. So which rock category, igneous, sedimentary, and metamorphic, does that? On 20, do you remember me talking about the rock that would have been like mudstone, but it's been pressured a little bit? So it's thinner but harder. That's what this is. So it's getting some pressure and heat. See if you can figure out which rock that is. Hopefully this will help you complete this lab and get moving forward in the right direction with rock identification. So see you in the next lab and in class, virtually that is. Have a great day. Bye.